So a lot to go through today. We don't have a guest speaker tonight, but we have 3 guest speakers this week, and then next week we are off in Boston, so that'll be fun. So just to give people a quick overview of the week, today we're diving much more into the geospatial stuff. So I'm glad we kind of got some of the preliminary work done last week. Today we're going to talk about the different geotechnologies that are out there. We're going to focus, kind of hone in on ESRI, Google, and Mapbox, talk about them. And then tomorrow, Bill's going to do a big remote sensing lab, so we can talk about that. And to close out our lab tomorrow, we have the lead business development guy from Mapbox going to call in and talk to us. And he's been with the company, I think, for a good chunk of time, so he's seen it grow. It should be a really interesting conversation. Wednesday, we'll talk a little bit more in connection with the remote sensing about the aerospace industry. So there's some cool TED Talks on your list for this week, all about small satellites and hopefully, I think, some really interesting stuff. And we'll have a data scientist who does remote sensing data science come talk to us on Wednesday. And then we're going to kind of close it out by looking at some data visualization tools by the end of the week. So talking about big data and big data analytics and the tools that work on that. So we've got a lot to cover, but good stuff. Yeah, go ahead.
There looks like there's a lot of readings for tomorrow, but a lot of the links that I put up are really short.
Mm-hmm.
So I think that for the first 5 or 6 links with satellite imagery and so on, I think that, probably half an hour would probably be enough to be able to take a look at those. A few of them are video, 1 or 2 videos maybe, and then another 30 minutes or something. So it looks like a lot of them. It's really just to sort of give you a first pass and familiarity with what satellite imagery and what imagery is really. So try to look at this because I think it will help us a little bit in that.
Yeah, definitely. All right, so we're going to dive into a few technologies today, and I want to start off with the question of, so you want to make a map. What do you need to make a map? And I just want to take some answers. What do you need to make a map? Time, okay, yep. I like that. Actually, you know what, I'm going to go. What else? What do we actually need to make a map? Come on, guys. A what?
A place or location.
Okay.
Place.
So you have to identify the place, essentially? Yeah. Okay. What are those boundaries? What might we call that? What are the boundaries? Do they they're a tangible thing, right? They're a file. They're an actual data source. So I'm going to say we need data sources. What do we need then? Mm-hmm. Where would we get a scale? I'm gonna pull this. If you were to, using my phrase, if you were to zoom out, what might a scale or legend, those kind of map components, what would they be considered if you're making a map? Are you going to draw your scale? What do you how do you get it? How do you, when you're making a map, how do you get a scale on your map? Very literally.
Other measurements.
Okay.
Other data sources, I guess.
Are you using a tool for it though? I'm digging at something.
It's too abstract.
Yeah, go ahead, Maggie.
The software you're using.
Yeah, so I'm digging at.
Drag and drop.
Right, so we've got things that we need to put on our map, and we have certain tools that get us there. And we could break these into a lot of different places, but we're going to talk about those tools. So let's say I have my source data. I have some tools that I can put things on a map with. I can click a button that adds a scale and a button that adds a legend. What else do I need to have to make a map? What do you guys use? Very literally, yeah. When you guys are actually, whether you're physically drawing it or using the software.
Cardinal direction. Where's north?
Yep. So I'd say that kind of falls into, well, I'll put that on. We might return to that. Okay. I'll just say direction. What else? Yeah, Jason. Key, yep, okay. So these are all like map elements. Can I like put that in a big bucket here? So like elements are like direction, key, legend, scale. Oh, I already have scale. Yeah, just shout them out. What else?
Projection.
What was that?
Like a projection.
Yeah. Okay, so now we're getting somewhere. Projection is, where do I get a projection? Where do I get one? And it doesn't, yeah, okay, so keep going. So you know that when you log into your ARC, you're going to pick a projection, right? Do we have any idea where this projection comes from, except for that ARC has a nice little list of them for us?
Something.
So there's some saved, okay, so we'll return to this. So we need a projection. What else might we need? Yeah.
Like a platform to distribute it.
Yes. Okay,
Or
so
printer at least, right?
potentially. So I'm going to call this like a sharing capability because our platform for distribution, I like that word distribution, could be a printer, or it could be a web tool, or it could be an app. Could be a lot of different things, right? We're missing one kind of big thing. So I have all these things, I'm putting them on a map. How do they all kind of make, is there any underlying feature that makes them all fit together?
Base map.
Yeah, we're going to start here with a base map.
Base map as in layers.
Sometimes it's layers, sometimes it's a database. But essentially, we're always, and this is why I'm going to come back to projection a little bit, we're always starting with, at least in ARC, we're choosing kind of our source data and our base map, and then we're figuring out how to connect the two. And we're missing, once we do that, what are we missing in between? So let's say I picked a base map, projected my data, I've got my source data in. I have a tool that integrates those things. So I'm going to add that list in a minute. I have a tool that integrates them, and now what? I got a bunch of things laying on a map. I haven't quite gotten to adding my scale, my legend, my cardinal direction yet. What comes in between? We're missing one other big component.
Colors.
Yeah, styling and visualization. That's like another big kind of bucket. So that's another set of tools. Sorry, you probably can't see this. So all of these things we need to make a map. We need a set of three things I'm gonna say. We need data, tools, and infrastructure to do all of these things. So the first thing I need is base map data. There are a lot of different base map sources. We're going to talk a little bit about that today. Then I need my source data sets. That could be imagery, it could be parcel data, boundaries, all the files that you're familiar with. That's your source data. Then you need your tool or your infrastructure to integrate them, right? They don't exist in a vacuum. If you're making a map, we go way back. If you're making a map, some of these tools were your pen and paper, or your physical scale. Those same tools are still relevant today. They're just a different set of tools. So what we're going to try to work through today is comparing all the different offerings out there for tools and infrastructure that provide you these different things. So once we've integrated the data, we analyze it, right? Typically, we're not just putting points on a map. Sometimes we are, but a lot of times we're asking a question of our data, so we need the tools to analyze it. We're always visualizing it, we're styling it somehow, and then we're sharing. I actually like the word distributing better, so I would replace that. Do we think we're missing anything? Okay. So we're going to talk a little bit about that first component, base map data. Does anybody know anything about the base map that you usually lay your data on top of when you're making your projects? It's okay if you don't. I wouldn't have known anything about it. I kind of follow it a little bit more now because it matters more to me now. So map source data comes from, I would argue, a handful of companies that create big base map source data sets that all of us in the GIS community use. Who can name a sourcing? OpenStreetMap, definitely one of them. Yep. Anybody else? TomTom, yep, that's one of the other good ones. Yep. There's two more big ones. One of them you might not know, even though probably most of your data comes from them. One of them you definitely know. Most familiar base map in the world is
Google.
Google. Yep. Anybody else? There's one more. It's kind of out there.
TeleAtlas?
TeleAtlas is actually TomTom.
Okay.
TeleAtlas was bought by TomTom. Yep. So the last one is Navtech, a company called Navtech. So a little bit about Navtech, and I'm going to start with them. They kind of were the first people to dive into creating this idea of a big source base map, right? Now, USGS obviously has been collecting this kind of information for a long time, but Navtech was the first company that came at it from the perspective of navigation, of getting you from one place to another, okay? They started in San Francisco, and they used actually dead reckoning, which I don't know a lot about, but it's basically a manual technique where they would figure out directions, and then they would manually correct these directions, and they came out with the first GPS type system, and it only worked in San Francisco, and they could install it in cars. So that was where Navtech started. Navtech came to be one of the biggest suppliers of base maps, and actually it wouldn't surprise me, and I couldn't figure out in everything that I was trying to figure out who ESRI uses, because I know you can pull in a lot of different base map sources, but I'm positive that at some point ESRI would have used primarily Navtech data, because they were kind of the ones that were out there. A couple of years ago, Navtech was bought by Nokia, and they're now called Nokia Here. It's like a division of Nokia. And it's an interesting scenario, because obviously we don't know Nokia as a geospatial company. So that's a little bit about Navtech and kind of how that's come to be. And there's some other companies that we read about last night that have a lot to do with base map. Can anybody talk to me a little bit about the situation? Who can like summarize the article about Apple and what happened when Apple went to enter the mapping space? When Apple entered the mapping space. We had an article about it last night.
They use the same base map as Google, but they don't have the extra stuff that Google has done with the Street View. So it didn't really work out at first. But yeah, they use the TomTom base map.
Yeah. So what did that prove to us? Apple, well-known company, right? They say we're going to do our own mapping thing. It comes out, it's terrible. Everybody knows it's terrible, and so what it really proved. And you guys really should do the reading so we can kind of crank through this stuff faster. But what it showed us is that mapping data is really hard. It's a problem of scale, and there's very few companies that can tackle collecting that much information on such a big scale. So creating base map data is really time consuming, it's complex, it's computationally heavy now because we have to collect it all in a digital format, and it requires precision on a massive, massive scale. So that's really what Apple's entrance into the mapping space kind of showed us. So base map data, there's 5 different reasons why we care, or the things that we consider when we think about base map data and why we care about it. So base map data products, we just named a couple of different companies that offer different base maps. And we care about how they collect that data, how they store it, how they visualize it, how they correct it or reconcile for it, and how they access it. So can anybody kind of summarize, there were a couple articles last night that touched on different ways that base map data is collected and sort of the scale and ways. Can anyone summarize what some of the ways are that base map data is collected? Google was one big example. Yeah, Emily.
Google and the other ones have people on foot also collecting data so satellite.
Yeah. Yeah, Google has driven 5 million miles of roadway in order to collect all of that Street View data. So Google took a very manual approach, but Google's one of the few companies that had the resources to be able to do that. Did I see a hand? No, okay. So we care about how it's stored, how it's displayed. When we talk about how it's corrected, so let's say all these companies have different methods of collecting this data, but we know that a lot of times they're wrong. Right? I mean, who's had their GPS take them somewhere that it shouldn't have taken them? Or we've all read about the woman who drove her car into a lake because it said there was a road there. So there's errors in the data. You haven't read that story?
No.
Oh yeah, it's,
Come
I'll
on.
show you. If we're
no,
going-
she literally drove right into a lake.
If
But
we're going to Boston, I'll show you a place there's a railroad crossing where they have all these signs that say this is a railroad, not a road, because some old lady showed a road.
ooh, yep, and she just
onto
drove.
the tracks, train coming
Yeah,
along.
she went.
Yeah,
and,
bad
She
situation.
just thought it was a. Who knows what she thought?
So it
Probably
happens,
nothing.
you know. I mean, all the data, and there were some examples in the reading last night where it showed visually rectifying different images where you could see very clearly, like the data's a little bit off from the street, and that's a big problem. So when we talk about correcting or reconciling that data, what are the things that we maybe care about in terms of, you know, if I have a base map, what do I care about? What is it delivering to me? It's delivering, number one, we want accuracy when we talk about how it matches a point on my phone to a point on the ground. Like we want accuracy in its rectification. A lot of times we want the information to correct these things are often crowdsourced, right? So they'll collect information from OpenStreetMaps is one example, but Google uses crowdsourced information to correct all of their maps. And they make most of their corrections manually, actually, by teams that are sitting around just like reading these errors as they come in. They go in, they access the base map, they change it, and then it goes, you know, back out immediately. So there's a lot of manual error correction that happens. We also care about coverage, so global coverage and frequency of update. It's a similar thing that we care about when we talk about satellite imagery. You know, if you're living in a city that's growing very quickly and there's lots of new development, it doesn't help you very much if your base map on your Google Map app is only updated every 2 years, because you're going to have friends living in some new apartment building that you actually can't find on your map. So we care about global coverage and frequency of update. And then we also care about how we can access it, the different form factors. So we care about whether we can get it on our mobile phone, whether we can get it over an API for developers, and we care about if it's on the web. So this is where actually companies like Google and OpenStreetMaps are very quickly eclipsing. I mean, Google 10 years ago really eclipsed some of these other big companies that didn't have this stuff available on the web, plain and simple. They didn't have it all ready to go and be pushed out on the web. So these are the big companies that we care about when we talk about base maps. Most of, actually, I would say probably all of the mapping applications that you use, whether it's Bing or, you know, whether it's an app on your phone, they're all using a base map from one of these guys, pretty much. And most of them are not using Apple. We talked about it. There are reasons why, even though Apple Maps has gotten a lot better.
I don't know anything about TomTom and how they collect data, but TomTom used to be TeleAtlas. Before it was TeleAtlas, it was GDT, Geographic Data Technology, over in Lyme, New Hampshire. And started by this guy named Don Cook. And Don actually, that's where ESRI got a lot of their data at first. Because Don and
Jack.
Jack were good friends. But they came up with this idea early on of trying to update their data, and that was a real challenge about 15 years ago. Just how do you update all these data, the roads and stuff? So they started an entire program to try to work with cities and get people from the cities to buy into this. And the cities would do the updates and send them the updates. They would incorporate them, and then any city that was part of their agreement would get their data back free. So in other words, there was sort of a mutual agreement. I don't think it worked at all, and then everyone came Google and all these other groups that had all the data, you know, up. And then they were selling it. I mean, you know, if you think about, what was it? It was UPS, FedEx, all these. A data set for the entire, a roads data set for the entire United States from TomTom, TeleAtlas, GDT actually, was well over $100,000.
It's really expensive.
Could have been $200,000. Yeah, and it was just incredibly expensive. You couldn't get it, and you had to pay. And the only ones that could afford it were these really, you know, it's big guys. And then of course along came Google and all them, and they had to completely rethink how they were going to get data, keep it up to date, and they couldn't sell it. They couldn't sell it anymore the way they used to.
Yeah, I mean, it's the cost. The importance of what Google brings to the table in having the cost come down. I mean, 5-6 years ago, I was with a company that was using NavTech data, and we needed it for the whole US. And it was like a ridiculous line item for us every year to be able to have to buy the full data set, and it wasn't good. It was never up to date ever. You know,
Really hard to keep it up to date.
they didn't have the infrastructure to update it fast enough, and for smaller companies, you couldn't afford. It was hard to afford it, to build new products. So what happens then is you end up keeping a lot of people out of the geospatial market because the cost of entry is too high to have something to start with, because you need the base map to start. You need some frame of reference. That's your contextual reference for everything else that you build. So if we're, and this is a very high level theoretical question, but if you're choosing a base map, so let's say, you know, I know when you're using ARC, you have access to certain things here at Middlebury, but let's say we have a new client, we have to decide, we're creating a map for them, we have to choose a base map. What sort of things might we consider in choosing a particular kind of base map? Yeah.
What do they want to use the map for?
Right, and why does that matter?
Well, because if the base map is satellite imagery that has a whole bunch of trees on it, and they're looking for a road map, well, the trees are just going to be distracting, so you may as well give them a base map that's a road map.
So we care about format, and we care
Yeah.
about end use.
Yeah.
We also probably care about the end user, right?
Yeah.
So are they highly sophisticated? Do we want this to be really simple? What things do we want to highlight? So let's say they wanted a map for cycling and trail running. How might that influence what base map we would choose? Yeah, Emily. Something with topography, yep. And some of these won't have that, right? So then we have to remember base maps are essentially a big database of a whole set of underlying features, and not all of them will be the same. So as we'll talk about, some companies are competing based on what features they offer you access to in their base map. So if you need something that tells you what's uphill and what's downhill, but one company doesn't have topography or they don't calculate uphill, downhill, then you're probably going to go with the company that offers you that attribute in the base maps so you can have that and query it. What else might we want to consider? Yeah.
The amount of size or the amount of space the base maps are going to take up.
Yeah, sure. So scale, huge thing, right? So if we have a customer that needs a map of the whole United States, not only do we want to consider the scale that we need that first map at, but we also want to consider the scale of the project in terms of, are they going to be accessing this every single day, 20 times a day, 500 times a day with one user? Is it a map we're going to print? Is it a map that needs to be up to date every single day? Some of these base maps will be better for printing, and some will be better for constant web use, right? So we want to consider scale not only in terms of the size of the area they're looking at in terms of coverage, but also scalability in terms of actual technology we're going to employ to provide people access to. What else? Anything else? We got most of the things. I would add accuracy we care about, and maybe data load capability. So we haven't thought much about that, but when we think about let's say a really popular app that's going to have hundreds and hundreds of thousands of people accessing it every day, we're going to eliminate some of these that can't be used on the web because they're not capable of handling massive data loads. So things like that will help us drive a decision there for a base map. So with that said, no matter what kind of map we want to make, we've got to go through a couple different things. We start with a base map, and we have.
Nice.
We care about, yeah, right? That's good. It's a good shot, right?
Yeah, remember that.
So we care about our base map data, we care about our source data sets, and then we care about our tools. So you guys were kind of getting at this, and I would say it's tools to analyze, tools to visualize, okay? Those are the two big things, and then tools to share or distribute. And I don't know where we'd put the legend, scale, map components. That actually might be like a sharing, distributing, end user, what do I have capability for? I actually used a platform for a year and a half, 2013, where we could not put a legend on the map. Like, it was a problem. We couldn't give our end users a legend. So let's keep considering those kind of elements as we talk through these companies.
I forgot to bring it up, but I have it. I have a file that, the original file that you needed to use in order to make a map with that very program there.
No way.
Remind me, I'll bring it in the morning. It's just like it's just like 3 pages of code. And you could, I think you could get a legend on the 3 pages of code. You definitely get like the boundaries read.
Oh my God. A different world.
Remind me, I'll bring it in. It's great. It's great. I bet it was still on too.
It probably would.
With PCR.
So, diving in here, ESRI. We're going to start with ESRI. They're the gold standard. I'm actually not going to talk too much about them because I think you guys already kind of know a lot about ESRI. But ESRI was started back in the 70s, and I just loved this picture because I kind of got a kick out of it. The sort of high points for ESRI, they were a bootstrapped company. Jack Dangermond is their CEO, and he is kind of like a GIS god. And I would say that when I'm thinking about ESRI, they're so successful in this space, and they are actually really synonymous with GIS itself. It becomes difficult at this point that we're in right now, where we're starting to see other companies, encroach on the market a little bit, to distinguish or to separate ESRI from the concept of GIS, because they've really defined the GIS tools that we have. They've defined more than just the tools. What else do you think they've defined? I mean, they essentially created the structures that we know today. But there's like another couple things that are all really ESRI standards that we know today. Not just the tools themselves, but what else?
Data formats.
Yep, the interface. What we call everything, right? The fact that we use the word join. Some of these things are database terms that were around before ESRI, but
join isn't actually. Join is not a standard database term.
Right.
It's relate that would be a standard database term.
Right.
So ESRI came up with this, as soon as everybody knows it that way.
Mm-hmm. So all the things, shapefiles, those are proprietary ESRI, essentially ESRI format files. Those were really all created by ESRI. So,
yeah, it's great.
What would you add, Bill? You've got
just that. A shapefile. It's so ubiquitous anymore. It's the most commonly found format anywhere in the world of a GIS file. And the guy who created it, there was this PC Arc Info thing here, and there was no such thing as a shapefile. There was a thing called an Arc Info coverage, and they were very clunky, and you had to move them around, and they were hard to move. And they came up with this simple little program called ArcView, so you could look at the data. And the guy who wrote it came up with a shapefile. He thought, nothing of it. Well, it turned out to be the file and what ESRI did, and this is the first time they ever did it, was they published the format of the shapefile so that anybody could read or write it. And they didn't plan this. But because it was the first one published and it was part of ESRI, PC Arc Info, and ArcView, everybody started reading it and writing it. And it became the de facto standard everywhere in the world.
Right.
So they did some things that were not really planned out, but there was one thing that was very planned out that they did, and it was very smart. And that was, of course, they're Environmental Systems Research Institute, so they started out as environmental, but they wanted to get their software into the hands of as many people as possible that were going to be customers. And they identified the customer base to a large extent early on as, private sector, but also municipalities and government. And so what they did was they ended up, to a large extent, giving the software away to making it readily available to a number of non-government organizations and so on, getting it in the hands of non-government organizations. And then knowing that those non-government organizations were working with government organizations. And so by giving a lot of their software, it was very strategically, people just started using it. And then government agencies wanted it. And then all of a sudden, once you got somebody hooked, it's like with AT&T or whatever, your phone company. Once you're hooked, You're not going to go somewhere else usually. And so by giving a lot of it away, they got it in the hands and they got it out there. And it just grew like crazy. And then government agencies started using it and buying it because they were working with non-government agencies, and then said, well, what do we use? And, so they were all buying ArcGIS or ArcInfo at $14,000 a license. And that 1986 and 1988, we paid $14,000 for a single license in the private sector, and it's still $14,000.
Yep.
And that meant, and that was a single-use machine right there. You just, that's a single use. I could sit at that machine right there, and I could pretty much, I had to write it all out, and there was nothing else that machine could do, nothing else that I could do in that whole day, And it was really pretty. It was pretty limited, but it was so cool, and it was so incredibly cool that you could do this. And so they were very smart in that way, and Jack was pretty good businessman there, and found a lot of the best programmers around, and got them on, and was very flexible. And he's an awfully nice guy. He'll even. I mean, I was at a user conference about 3 or 4 years ago, and I was looking at the map gallery, and he just walked up, and he and I were looking at this map gallery. We were supposed to spend 20 minutes walking around looking at the map gallery. He was just so excited about all these maps. He's still that way, and he's just genuinely interested. But he made some very good strategic moves, and I often wonder, though, and maybe we'll find out more as we go on this semester. I think of like companies that have reinvented themselves, like IBM. And how many times has IBM reinvented itself? And you think it's just going to go belly up. In some ways, maybe Apple, although maybe they got lucky. But IBM and ESRI, I think, in some ways has maybe reinvented itself recently. But with Mapbox now and some of this competition, which we're about to talk about, I wonder how much they can, how well they're going to reinvent themselves, and I think we're going to find out about that. But it has really, it is changing all the time, but they've been pretty good in many ways. I don't know, they pulled themselves out a few times when I thought they were going to go under. Somehow they reinvented themselves.
Yeah. Well, did anyone catch? Who read the article last night on Jack Dangerman, the Forbes article? Yeah. So did anybody catch the piece about R&D in there?
What did it say about R&D?
So it said that they spend an average of 2 times more than most companies on R&D. So whether or not you can point to that as being the single thing, I think it's impossible because they've gone through so many shifts. But they did say they're spending like 28% of their budget on R&D every year. That's a lot.
And early on, not even early on, I mean, it's awful software. It's really terrible software.
It's really not good.
Really awful. I mean, in some ways it's awful. Like the interface is way better than it used to be. But it's so buggy, and there's people that would work for the company, and like I've used it here since I've been here in 2000, 1999, and it would just be. I remember one student. We used to have a end of semester project, and it was like a week and a half or 2 weeks long, and we had ArcView. That was before ArcGIS. And it had these things called segmentation violations. And there was about 1,000, I'm not kidding. There were about 1,000 different ways of getting a segmentation violation. And some of them you could fix, but some of them were just unfixable. And so this one student, she worked for like 2 weeks on this project. It was all due, and she was ready to print it.
Oh.
And all of a sudden she gets this segmentation violation. Oh, great. I felt so bad for her, She went back and redid the whole thing. It was just amazing. But that's how, and if you look at the tools even today, they work differently. Like one tool will have one language and one tool will have another one. They do almost the same thing, like the spatial join command. It's spatial join. We used to use it when Jeff would have us use a spatial join command. There's another way to do spatial join. It's a completely different tool. It works. It does conceptually the same thing, but it works completely different. It's like, who the hell is... They didn't talk to each other, and they still don't talk to each other. And they grew so fast, they grew exponentially, that they weren't really, their quality control was terrible. And that's where they did spend a lot of time and effort in the last 5 years on that. But before it was terrible.
Yeah. Well, and I think what you just said, it's actually a really good segue in the sense that ESRI has really been the only. There was no other choice, so it's really nice to be the company that can pretty much do whatever you want because no one has any other option. But we have to remember, and what you just said is exactly what I'm about to get at, where there are many ways to complete a certain operation. So when we think about a spatial join, simple operation, in ESRI alone, there's multiple ways to kind of execute that operation. The other tools that we're going to talk about today have the same types of operations, but they don't have the same type of interface. So when you use that word, Sam, interface, ESRI has a very specific type of interface, and the new tools that we're seeing come out today have a lot more to do with coding that join and asking for that joined information back, but never having a button where I can define the join myself if I can't code. But we have to remember that even though the interfaces are very different, the actual operation being executed is the same. So that's why we can compare some of these tools that are still very different in a lot of ways, but we have to remember the underlying operations that we're executing on are ultimately the same in a lot of these tools.
You mean in a lot of which tool?
So we're going to talk about Google, and we're going to talk about Mapbox. Just the fact that in ESRI there are multiple ways to do one thing.
Yeah.
When you take those same operations and put them into totally different interfaces like APIs and you can do HTML, CSS coding and get the same kinds of results and styling that you can get through ESRI's interface style my map tools, and I'll show you guys some of that today. So the point is, the operations, many ways to skin a cat, right? That's where I'm going with it. All right, so the last thing I would add about ESRI is that in 2012, I think it was 12, they came out with ArcGIS Online. And that is a really big deal because, as Bill was saying, they kind of had been catching a lot of heat for how buggy their stuff was. Google had come to market to the consumer market with free software, but came to market with Google Maps, and we're really changing the idea of what mapping should be and what it should be about. And ESRI did not have an answer for a web-based, we like to use the word portal. How many websites do you go to that have a little map embedded in them? It could be like a restaurant. They're going to give you directions. Well, ESRI didn't have an answer for that. They didn't have a way for any ESRI user to take their map and embed it on a website. So AGO, ArcGIS Online, was the answer to that. And it's really important because it's their only answer to the web interface that is driving our whole economy today. So it's a very critical tool. Has anyone used AGO online, the online tools? Okay.
Yeah, we have licenses. Actually, before that, they had several products, but they were incredibly clunky.
AGO is still pretty clunky.
And they were really hard. They were really hard to program, and you needed somebody. Not only did they require somebody who knew hardware and sort of computer backends, they needed software and programming, and you could do the basics, but when you got past the basics, it was really difficult.
Yeah.
And then along came all these other things that were so much easier. And this is you're right, sort of their catch-up answer to Mapbox and Google. We'll see.
And actually, if you guys, in the article I was just mentioning, the Forbes article, Jack was quoted saying, oh, well, those guys at Google are our friends because they brought maps to the public, and that's been so good for our business, but I promise you, they are not friends. In some ways, yes, it's great. The democratization of maps, getting them into the hands of consumers, really important for Esri's business, but he was only able to really comfortably say that once Google decided to deprecate their enterprise geospatial tool, and they knew that they were kind of out of the woods competing with them on that enterprise GIS tool. Which brings us to Google. So Google is a very cool company in a lot of ways, but a very complex company. So their overall mission, the overall mission at Google, and it goes back to search, right, is to organize all of the world's data and make it useful. So when they created search, what they ultimately did was they indexed everything on the internet so you could search for it. You can apply that same indexing concept to geospatial data. So when they started to get into maps and collecting all this base map information, the concept was, can we index all of the location information on the face of the earth and let people search for it, which is what gave birth to what we now have when you can go into your Google map and type in, like, I want pizza, and it's going to give you all the pizza places near you. They're indexing location-based information. So
This is probably really obvious, probably know this, but the word now, I think it's in the dictionary now, isn't it Googled or something? Googled?
yeah, like it's a
Yeah.
verb.
Maybe it was, but I mean, it was the first really search engine that was so incredibly effective. Yahoo was out there, and all of a sudden, and all these other ones, Dogpile. I mean, well, Dogpile was just took all these other search engines, but you know, Google came along, and the algorithm was so incredibly efficient that, you know, it just blew everything away. And I mean, we use it, we take it for granted now, but it was like nobody could believe, and all of a sudden, Google, I mean, literally overnight almost.
Yeah.
It just took over as a search engine. It's just amazing. I've never seen anything like it.
Yeah. So they took the same philosophy of search and they applied it to geospatial information. Now, that worked out pretty well for them. They can now claim that they have the world's #1 map. It's the most recognizable map in the world, without a doubt. It gets used more than any other map in the world. It has the most intuitive, arguably the most intuitive user map interface. Others are now catching up, but 5 years ago, if you had another type of web map, it sucked compared to Google's. I mean, it didn't matter what it was. It just wasn't as slick, wasn't as easy to use. It wasn't as fast either. So these are just some stats from Google. 1 billion Google Earth downloads, and this data is a couple years old. This is from...
And I'd just like to say one thing,
Yeah.
and that is so true. But this has hurt our bottom line here at Middlebury, because a Middlebury grad started MapQuest. And when MapQuest was the #1 map tool, we were getting some pretty good grants here at the college. And now
Is that
MapQuest
true?
is not.
Not so much.
There's some problems that we have with getting funding for the geography department. So, sorry about that. But
Well, there's some good news about MapQuest from Mapbox.
yeah.
I'll tell you about it later.
Good.
So Google Maps, obviously we got some big numbers here. 250 million active mobile users. That was 3 years ago. I'm sure that number is higher. Google Earth is kind of the companion product. It's an important product. I'll talk a little bit more about it. So good stuff. And basically, in a nutshell, massively popular, enormous scale. So when we think about Google, we can always think about problems that require enormous scale and massive amounts of resources. It's what allowed them to basically go out and do something like mapping the entire globe. And so we have to remember that their base map data, they have certain things that they started with. Most basic things, roads, intersections, directions, and then they've expanded it obviously to all the other things, businesses. So they have a whole collection of that base map data that's called Places. So there's a Places API. It's a database your app can call, and it will give you back only information on all the places that they have stored. The other thing, and actually Sam, you brought this up the other day about Street View, about could you index Street View? And so they're indexing words that they capture in Street View. So they can actually use optical character recognition to index street names and business names, but I haven't encountered them indexing anything beyond just the written word, because they have algorithms that can detect the written word. But if we can get to the point where they could detect, we were talking about the drought in California, could they detect whether you have grass in your front lawn? I'm sure that's the question they're asking. I don't think it's far away. I don't think it's far off. So again, we're just thinking indexing, collecting all the information so all of it is searchable, right? And yeah, massive scale. And scale, when we talk about scale, we have to remember it's not just in people power, right? They have a lot of money, they can hire a lot of people, but it's also computational power. So we think of the big computing capabilities now, Google and Amazon, they're really making a lot of things possible that weren't possible before. When you just talked about your computer being able to do one operation, have one program open in a day, the fact that we have companies like Google and Amazon that can take on just massive scale of computation in and of itself is helping us solve a lot of problems in the geospatial world. So I'm going to take a really brief, like, kind of sidebar here to explain what an API is, because a lot of Google's geo products today are APIs. Now, does anybody know what an API is already? Because I have to be honest, this is not my area of expertise. I have a vague definition to share with everyone. But all right, so an API, and this I love this picture. It's as simple as it gets. But an API is essentially a mechanism that sits in between two systems, and it allows those systems to communicate. Right? So it's basically my own app, let's say, calls over an API. Consider it the phone line. Calls Bill's system, and it asks for something very specific in a language that Bill's system will understand, and it translates the answer back to me. So it's a method of transferring data. Am I right, Lucas? You're in computer science. Am I getting that right?
No.
Oh gosh, I thought we had somebody nobody's in computer science.
I think you're.
Okay, so I can't make too big of a fool of myself. All right. But yeah, so that's the concept of an API. And it's important because when we talk about these base maps, the reason I started there is because a lot of these base maps are giant data sets. They're data sets of directions, they're data sets of places, they're data sets of elevation, terrain, and with an API, you can call that data and only get back, let's say I'm back to the bike cycling app. I just want to get back all the bike paths and the elevation data. So I'm only going to call the terrain API and one other API that's going to give me bike paths, and that's it. So these different APIs are actually products that compete with the same things that ESRI does. And that's why it's kind of important, because they're a different type of product, a different interface, right, for the person who wants to get the same result, which is to have on a map my bike paths and my terrain, but it's a different path it's a different tool set to reach that same end goal, which is to have a map with my bike paths on it. Make sense as much as it can? Clear as mud? Okay.
But that's, I think, you're going to talk about it. Just a year. Go ahead. We'll come back to it. But it's pretty critical. It's revolutionary in many ways.
Mm-hmm, mm-hmm.
I mean, you may not think so, but like, for instance, anybody in here now, because of these APIs, you can make your own application and you can customize it and do whatever you want and market it but you're using this back end other data sets, these big data sets in there, and you can interface with them using that API if you know how to use that API. So it opens up huge opportunities for businesses because your app is on the front end, right? The business,
sure.
And then theirs is on the back, and you're using that, and there's that interface between there, and it just if that API is published, it becomes
super valuable. Yeah.
Endless.
So how would y'all could use maps so that they could help you find food that you wanted? Like, is that what's going on there?
It depends on how their infrastructure is built, right? If you're Yelp, you probably do, and we'll talk a little more about this, but you probably buy a base map that you subscribe essentially to a base map that two things. You have a base map you display, and then you have a base map that you query, or you have a base data set that you query. Right, exactly. So I don't know who's providing Yelps. There's a very good chance it's Google. I mean, that would make a lot of sense. So, I mean, the vast majority of tech web applications right now use Google because they have all the infrastructure there. It's not a great answer, but you could probably look it up and see what Yelp uses, what Uber uses. But we got to remember, display is also different than the query. It's different than asking for the information on the base map. Two separate, they could be the same company that's doing both, but it could be different. Yeah. In the dark. All right. So this kind of brings us up. Oh, Jess, do you have a question?
Yeah. Isn't Google Earth like an API?
Google Earth has APIs as well. Yes.
So what does that mean? Does that mean that?
So Google Earth is another. Think of it as another giant database.
Yeah.
And I actually am not familiar with all the individual attributes that you can query over the Google Earth API, but I would imagine it's much more physical land data like terrain, for instance. So if I wanted a terrain model or if I wanted a 3D like I have in Google Earth, I'm going to need to query the Google Earth API and not the Places API. They also have geocoding APIs. I'll show you, you know.
So Google Earth itself is an API, not like a database, or
Nope, it's
are there
so
APIs that work with?
the thing that, and this is not you. This is the thing about Google is that kind of everything falls under this umbrella like Google Maps and Google Earth, but there's actually like dozens of products that get split out. So each API is its own product that you would pay for. Google Earth is its own product that you experience on as an end user that you go in and you check out. That's a product. But then the actual API is another product. And they have the same base data set that they're calling from, you know. So like when you're looking at it and scrolling around on it, it's calling from the same base data, right? But you have a different, like if you were to pay for Google Earth Pro, you'd have to also pay for the API. Different products, but same base data.
Okay.
Does that help clarify?
I think this Mapbox example.
The Mapbox example I think will help.
Yeah.
Yeah, so Mapbox is the third company we're going to talk about today, and they also have a bunch of APIs. And so, for instance, are we all familiar with geocoding from, I don't know what you guys cover in GIS now. Are you familiar with geocoding?
Yeah, I think we covered geocoding, didn't we?
Ish.
Really simple, just an address. Everybody's done it, you know.
Yep.
You're going from one location to the other. But,
Yeah, so to geocode, I'm just going to match a lat long or a street address to a physical point on the earth. Usually I'm going to go from an address to a lat long or a lat long to an address. There's other formats, but it's just basically matching, you know, a spreadsheet of street addresses to their lat long location. That's what geocoding is. Like, show me the point that this is on the earth. So, and Mapbox has got a great website. So Mapbox does all of this over an API so that you can, it will return, you will send it all of your information, and all it will do is just magically return you all of the points on the map. So it does some of the work for you, and it's going through its own base map, OpenStreetMaps, and it's matching, it's got all of its own code, and it's matching all those points to a place on the map. So that's an example of an API. So if I knew that I had customers that were going to upload a street address and wanted to have that point translated into a lat long, I would need to buy this geocoder or pay for this geocoding API that would return me that point on the map, that lat long.
so I used to work for a florist company. And when I was in high school, we had to, before I went out every day, the boss had to figure out where all the flowers needed to be delivered. It's kind of funny, but, and so he'd give me this physical map, and I would have, with all the addresses and the points on it as best he could find, and we'd sit down for like 20 minutes beforehand. And he'd have to draw out where he knew about the area, and there were always these holes I could never figure it out. But so if you were the florist now, you'd get all these addresses, you'd get all these things, and maybe you batched it at the end of the day, or and you typed them all in, and then you could send that whole batch. You'd have a little interface, and you send it back, and then Mapbox is going to locate them all and send you back a nice map that you print out for the person going out.
Right. And APIs are a little confusing. I'm not going to, it can be a very complex bunch of products, so I'm not going to expect you guys to totally grasp every little thing about all these many, many, many different APIs that are out there helping us in the geospatial world. We just want you to know that there are giant databases, and there are these things that people have designed that allow me to go and access exactly the answers that I need for a given problem. For example, geocode me these addresses, great, send it back to me. Pretty high level, right? So with this whole concept, let me click on this. Oh, no, go back. All right. So with this whole concept, in 2012, Google, or maybe it was a little bit earlier than that, Google announces they are going to enter I'm going to say the enterprise geospatial space. Now, what advantages? So up to this point, Google has absolutely destroyed the market on the consumer side in terms of free mapware. They came on the scene, and they've essentially created new standards themselves, just like ESRI had. So what advantages might Google have in saying they want to now charge people? They're going to create, nobody knows what this is going to be. It's just like, oh, we're going to create an enterprise geospatial tool of some sort. Nobody knows what it is. Why might ESRI be nervous about this? If you're 2011, you're ESRI. Yeah, Maggie.
Google's really user-friendly and Esri is not.
Really user friendly. Yeah. Were you gonna say something else? Base map is super recognizable. Yeah. What else?
I think Google was great for on the consumer, on like the ordinary consumer end, but for people who actually wanted to make maps, Google was kind of useless.
Yeah, they didn't have
Esri-
anything.
Yeah.
You couldn't make a map on it. I mean, you could put their map on your website, but you couldn't make your own map. Yeah, Emily.
Even like with a lot of the other Google products, like Google Docs, Google spreadsheets.
That's true. They have this whole, they're kind of like taking over your life. They know everything about you. They can have calendars and all these other things. Yeah.
I don't remember the term right now, but creating a new market with users that weren't involved in mapping.
Mm-hmm.
We talked about that last week.
Yep. Disruptive. Yeah, so they have the chance to kind of go after and I'm going to talk about this because it's really big. They have the chance to go after the non-geospatial expert. So this is really tricky because nobody who's not a geospatial expert is using Esri. Promise. So that's so that in and of itself would be enough to make Esri nervous. And then the last thing is really just that, oh, did you guys have other things?
Yeah, I was just gonna say they already have all this mapping stuff, so they could maybe transfer over to the enterprise side to make it cheaper.
Sure. So they have the base map infrastructure, right? Yeah, absolutely. Anything else? That's all I had, but okay, yeah. So Google comes out with this announcement. They're going to come out with this product called Google Maps Engine. Maps Engine Lite was the free version, and it started out pretty basic. You could add places. You could import a shapefile or a spreadsheet. If you imported a spreadsheet with street addresses, it would automatically geocode them, map them, which is a process in Esri. So it has already some like advantages. It could organize. You could put things in layers. You could style the layers, and then you could share those maps with people. And I'm going to share a little bit of this with you guys. So this is a very, very broken down version of what Google Maps Engine used to look like. It's got some pretty basic tools. So I can come in here, I can add a layer, and that'll allow me basically, I hope it doesn't freeze on me. It might. I can add a layer by importing a shapefile, and like I can pull it right in here. I can change my base map. If I really want to, and this is actually really fun, I can go in and make my base map whatever colors I want. They used to have like a little configuration tool, and I could go in there and like make my roads green and make my map hot pink, which is a terrible idea. I don't recommend it, but you could do it if you wanted. You can go in and add your own points. So this is familiar to you guys. You can digitize and add stuff. And again, this is a really simplified version because they have since stopped supporting Maps Engine. So a lot of the more complex functionality that they were building is not being supported anymore. But this just gives you guys a little bit of an idea. And then we have this googliness of being able to share it. So I can just say like, this is my Middlebury Geo-Business map. And I can share it with whoever I want, and I can add you guys on emails, and boom, you're just the same way you would share a Google Doc. So there's some advantages to this. I really love the word googliness. It's not a word, but we all know what I mean. There's these inherent characterizations of Google: ease of use, intuitive interface, and an ability to connect with people who are already probably Google users and other platforms. So this is where they started, and ultimately, when it first started, if you were a serious GIS person, you kind of said, okay, this can't really do much. Can't really do a whole lot. I mean, somebody just said this, that you couldn't really make a map with this. I can't do, what's missing from this? What's missing? There's a big component. We talked about a couple components in the beginning. Yeah. Can't choose a projection. They're doing that for you, but you can't choose it yourself, and sometimes it's wrong. Yeah, Maggie. No tools. I can't analyze anything in here. I have the ability to do some styling, so I can make my point, a different color, right? But I can't do any of the spatial analysis that really makes ARC. So when it first came out, we thought, all right, it's not that competitive. And when they launched Maps Engine, they launched a couple other things, or a couple other things were also coming out at the same time, one of which I'm going to mention was Earth Enterprise. Does anyone know what Earth Enterprise was? It's a big product for the government. So if you're a government and you use Google Earth, because man, it's pretty useful, and you can throw layers in there and you can map all different kinds of stuff, and you're looking at military application, what might be the issue with Google Earth? Emily? No privacy. Yeah, so Earth Enterprise was essentially an instance, a whole setup of Google Earth that was behind your firewall that was yours privately. So it would be like set up just for, let's say, the United States Air Force. Nobody outside of their firewall could access it. It was just there. So it meant it had to be hosted separately. But you paid for that and you had your own Google Earth playground. It was yours. So Earth Enterprise and some of these other products came out and a bunch of APIs that we've already kind of talked about. So all these things come out and what happens? What happens? This is one of my favorite stories. So Maps Engine was a couple of things. Number one, it was an attempt to monetize what they already had, right? So they had all this infrastructure. They weren't making any money on it. We all use Google Maps for free, which is nice, and Google does a lot of that stuff because they believe in innovative technology, but ultimately they're a company. So they're trying to figure out how to monetize all these geospatial assets that they've built. And they figure, okay, an enterprise mapping platform that I can have businesses use, and this is the goal, get businesses to use this, have all of their data stored here. And I had some customers who moved all of their data over to Google Maps Engine. Everything's there, and they're styling there, and they're sharing it there, and all this stuff. There's some great advantages. It would geocode automatically. You could style it easily. You could show it to your board member, and he would actually get it because he didn't need an ARC license to see it, and you didn't have to print it out. So it was shareable. It was great. And what really became their issue, well, can anybody guess what might have been their issue? We were talking about they got some good technology here to start. Yeah. There was, I wouldn't say this was the ultimate downfall, but there definitely was a perception, kind of like we see with water in California. Why do I have to pay for something that falls from the sky? You know, Google Maps is everywhere. Why do I have to pay for it? Yeah. You know, it had issues handling.
I used it and like you had to check every address manually to make sure it really got to the specific photo.
Okay, yeah. So what I'm about to talk about has a little bit to do with that. Yeah, so we had things like we had limits on the amount of data you could put on a map, 100,000 points. Well, that became a problem very quickly for some of our big customers. But truly, what was I think, and this is my opinion, but I think the biggest part of what kind of took them down was their business model. So they deployed this whole product and they start building it and they're adding features and they're checking what they should add next. They're getting feedback. And after about a year, it became clear they were really going to give ESRI maybe a run for their money. They're starting to talk about the analytical tools, which is really going to be where they could start to bring over the more expert users. And their business model was to have what we call channel partners sell the product for them. Now, Google's their big thing, when you think about Google, they're not consulting, right? They're never consulting on a product. They make cool technology and then they say, here, go out people and use this and find an awesome way to apply it. So Google would have channel partners resell and implement Maps Engine, and the partners would deal with the kind of end customers. So I would go out and I would sell an oil and gas company Google Maps Engine, and I would work with them, and I would get all their data loaded up, and I would do all that, and I'd report back to Google and say, great, I sold somebody your product. So if you were at that point, who do you think ESRI's customers were? Who do you think, what segment of the market, now you named one segment of the market, but what other segments of the market might Google Maps Engine have been attractive to? There's maybe 2 or 3 other ones.
You mean segments of the market? I mean, like, what was the one example?
So Bianca said non-GIS experts, right? It would have been attractive to the non-expert because ESRI is a complex software to use.
Maybe like smaller businesses would have been cheaper than ESRI's?
Yep.
Yeah.
Absolutely, yeah. Yep, Parker.
Companies that needed to get data back put in by users.
Back put in by users. You mean that wanted some responsiveness? Yeah, potentially. I hadn't thought of that. Yeah. So the other two that I would think are people that needed some offline sort of capabilities. Google was starting to offer the ability to, you make a change on your map, and when you get back into your self-service, we'll update it for you automatically. It's a really hard thing to do. Nobody's really nailed it down yet, but if you could count on one company trying to do it, it was going to be Google. And the last thing was, what was the other thing we talked about that we didn't really mention? We talked about it a little bit earlier. People that needed a lot of power on the internet. I'm going to have 100,000 users hitting this map, and it's going to be online. ESRI was having some issues. AGO was brand new. Nobody knew if that was going to be any good, and it's still a pretty clunky product. So we had non-GIS experts, we had web products, and we had people who needed offline and potentially people who were budgetarily restricted from having a ton of ESRI licenses or couldn't make it work for them. So Google comes out with Maps Engine. They go after those ignored market segments, and they're kind of following like what I like to think of as a 90-10, 80-20 rule. I know this is not really what the 80-20 rule is, but the concept that Google comes out with this is that 80% of the users only need about 20% of the functionality. So how many people out there just need to put something on a map and don't need all those excess features that they're paying for in ARC? Probably a lot. So they're kind of going after that that group of people, and in that way, Google started to charge for this product based on the number of map clicks that it got. So you weren't buying a single license. So we now have competing business models as well. So we've got ESRI charging by the license, a very expensive fee, and we've got Google charging by the map click, which is interesting because it actually can be very expensive, especially if you're starting out and you don't know how many map clicks you get. So your first bill might be like a little surprising, right? So we have competing business models. Yeah, go ahead, Emily.
So how does Mapbox work with the government?
Yeah, so every time somebody's using the map, even if it's the government scenario, you're still calling that database back at Google, and they know it's essentially like every time you tap them and say, hey, send me this. Oh, can I zoom in? So literally every time you zoomed in, every time, any time that more data appeared on your screen or changed on your screen, it kind of counted as like a screen refresh. So that was the two kind of competing business models, and they had the final thing is they had the resources to do this really quickly. So that should really scare ESRI because Google has the ability and the infrastructure to spin up a whole enterprise software if they really want to in 2 years, if they really chase this. And the question was going to be how much money were they going to spend on it, how seriously were they going to take it. So 2 questions for you. Number 1, do we think that this technology at that point had the potential to be disruptive? Did it have earmarks of being disruptive? Yeah? Why? Maggie? Going after a different market. What else? Say? They had some name recognition in some other areas, obviously. Yep, good. Yep, they have the potential to move up market. So once they have this non-GIS expert, they can start tacking on the GIS expertise. They can kind of ramp up the expertise scale, if you will. And the last thing is they're going after the market leader. If they start to move upstream, they're going after the market leader, which is ESRI, and they have the potential to kind of unseat them. If you were a company that wanted to work with Google, what do you think one of the risks might have been of jumping on the bandwagon really early and saying, yeah, let's do Google Maps Engine? Accuracy, potentially, right? But let me ask you this. Do you worry about accuracy when you use Google Maps on your phone? Not really. So why would you worry about it if you're a business? No, I mean, there's not a right or wrong answer, but.
Well, you can need it if you have someone searching for your business in the location. You need accuracy.
This is more riding on it, right? Maybe than you like being 10 minutes late to a friend's house. What else about Google? Yeah, Emily?
I kind of like to just release products and then wait to see what people come up with in terms of capabilities.
Yeah, so my team at this time, when we started to work with Google, we were a very early partner, and a lot of our potential investors used to say, well, they're Google. They're so big, they could decide next month they don't care about doing this, and they could just drop the whole thing. And if you build your business on using this product, you could be left totally high and dry. which is actually what happened in the end. So what happened? Google developed this whole channel partner network to resell and implement this technology. And they said they would support partners, but they would essentially, they'd get on a phone call and say, hey, we believe in this partner, because the Google stamp of approval goes a long way. But they would not provide any professional services. So they wouldn't actually learn your customer and learn what their needs were. Which brings me to my example here. So I had a customer who was in the energy space, and they ordered a whole bunch of imagery, and they had all of their data in Google Maps engine. They paid a lot of money for all of the Google imagery, and we can see here on the left side of the screen we have Google imagery, and then we have it compared to what they had in ARC, which was digital globe imagery, and they had it up in ESRI. Same data set gets pulled into both systems. What's the obvious issue that we have here? We got some registration problems here, folks. Our points aren't matching, and so for this particular company, they're tracking highly sensitive assets, underground assets. And so they actually had somebody walk this particular yard with, with a hand GPS that are accurate, incredibly accurate. I'm just going to say that. They're the most accurate kind of handheld GPS you can get that are not military grade. And so what we were constantly, as a partner, having to go back to Google and say, no, we promise something is wrong with the registration on your imagery. You need to fix it. But because Google wouldn't talk directly to the customer because they don't do services, so it's our job as a partner to kind of figure out this problem, we had this incredible lag time in trying to figure out this issue. So the partner doesn't have the capability to fix the technology when there's a problem, and the customer doesn't have the capability to talk to the person that can fix the technology, who lives at Google, whose job is to just push out the technology and say, here you go sell it. So ultimately what happened was Google started to kind of penetrate these different markets, but their response to these businesses was so slow, and they were so uninterested in, in knowing their customers' problems, that ultimately they ended up with a bunch of unhappy customers. And so for a variety of reasons, and we'll be at Google next week talking with the team who worked on this project, and we can hear more about what was successful about it and what wasn't, because there's obviously a lot of decisions that go into what a big company like Google decides to do when they pull the plug on this. But I'm going to say I think their business model didn't work that well for this type of enterprise geospatial application where all those decisions that we talked about earlier, where we said, how would you pick a base map, right? If you don't know your customer and their end use, how can you pick the right things for them? How can you make the right tools available to them? And so I think, for me anyway, it was incredibly disappointing because Google did have the potential to really disrupt the market, which I think is healthy. We want to see somebody pushing ESRI, and we want to see somebody really creating new tools out there. But ultimately, it wasn't a great play for them because their business model is never going to be to hire tons of people to go learn about all these different industries. It's not what they do. So it wasn't a good fit for them. Doesn't necessarily make it, whether it's a failure or not, kind of I think we could debate, right? But so that was just an example of that. There you go. There's a little bit more on the accuracy point there. So who read, there were two articles that kind of summarize the current ESRI-Google relationship. Can anybody kind of summarize that for me? Emily?
Is it Google, ARC is, ESRI's offering to give people ArcGIS for free for their first year and show them how to use it.
Yeah, so what came out of this, so Google Maps Engine, they announced they're going to deprecate the product. And it's kind of a big deal because they have customers on the product. They have all these partners like my company, and actually we're going to visit AppGeo next week, and they were a very big Google partner as well. So we all have customers that are using this platform, and now we have to go tell all these customers, well, sorry, you got to find something else. But immediately, what do you think happens? That announcement comes out. What's the very next thing that happens? We get a whole bunch of other companies going, oh, for everybody switching off of Google, we have a better solution for you. And that included ESRI, it included CartoDB, it included Mapbox, and a bunch of other kind of smaller companies that also have these mapping capabilities. And consultants like AppGeo who really don't care what tools you use, they just want to give you a solution that you're going to like and it's going to work for your problem. So this is what happens. We kind of have the dust settles, and when the dust settles, Esri emerges the winner. So right now, if you go to Esri's homepage, this is yesterday's. Okay, the two of the
I'm
biggest
not seeing
headlines.
this.
Yeah, the two big headlines are ArcGIS Earth. Well, what does that sound a lot like? And then the second headline here is Google and Esri, Maps Engine alternatives from Esri. So Esri's walking away a big winner here. They're essentially saying, we'll take on, I know there's been discussions between Google and Esri about how they're going to move all these customers over. And I think Google just said, we're not going to fight the fight. Let's get these customers off the platform. Esri's the easiest way to go. So this is actually what they're saying right now. If you had any of these products, so we talked about Earth Enterprise, I mentioned it specifically because they have all these big government contracts that now need to go live somewhere else. So Arc said, oh, guess what? We can do that. We'll give you, you got to match ArcGIS with a server and all this other stuff. So, but Emily's right. They're offering, not only offering the tools for free, but free training as well. So when we talked last week, and this is part of the reason we talked about starting a company, and we talked to Max and we talked to Lars, they talked about things like cost of acquiring a customer. So when Bill talked about when Esri first started, they're giving out licenses. The cost of acquiring a customer when you're giving things away for free is very high. But if you're thinking down the road enough and you think, great, I'll give it to them free for a year, then they're going to buy another 10 licenses, and I'm going to ultimately, it's not going to matter that I gave away a few for free. I'm sure that's what they're thinking. So the cost of acquiring these customers will balance out for them. I'm sure they figured in the end. But that should just tell you guys a little bit about kind of how things ended up for these guys. Now, where does that leave Google today? Oh, we can talk about this. Let me just see if I have. Yeah, I'll come back to that one. So this is where Google is today. And what they've essentially done is they've taken all of these things that were of value and they've basically put them into APIs. And I hope that I know it's kind of small. I don't know if I can make it any bigger. But they've basically said, these are all the different APIs you can access or subscribe to, all you developers out there. So now we're back to being the Google that we know and love. Here's our wonderful tools. Go build great things with them. So I opened a few so that you guys could see, but everything from business and POI, which is places search, so over 100 million business listings and points of interest that you can search and index. They have distance matrices, so from here to here, we're all taking that for granted now, but you can have your API, so if you're building an app and you want to know from here to here distance, Google's API, you pay for that, and however many clicks, you pay per click, and there you go. Predicted travel time, we've got satellite imagery, elevation profiles, drawing tools. So these things are a legacy of Maps Engine. They still have, back to this conversation, they still have the tools and the infrastructure that were built to get people that interface that we see in Esri, that they tried to compete on the interface in Maps Engine. The tools still exist. The infrastructure to draw points on a map still exists. But now you, the developer, can access those tools from that tool set. It's just not in an interface that me, the map designer, is going to access. Does that make sense? So this is where Google is today. And I just wanted to show you guys a quick example of, they're still working. They've sort of translated it into a new program. And, oh, that's not what I want. Go back. Let's see.
Patient outcomes. We want people to feel better faster. Doctor on Demand is a national medical practice that instead of making an appointment and sitting in a waiting room, you download the app called Doctor on Demand, and then you actually interact with our doctors over video.
As a physician, I'm always looking to eradicate disease. Here, I'm looking to eradicate the waiting room.
The average wait time to get a primary care appointment in the US is 18 days. We take that 18 days and shorten it to 3 minutes. Our main product and service are great physicians. So what we do is make technology that just makes the physician visit better. We had a couple different challenges to solve with Doctor on Demand that required geolocation technology. It's actually the law that you see a doctor who's licensed in the state you are physically located in. Given that most of our members are using our service on a mobile device, we were able to plug in the Google geolocation APIs and say, Google, here's the device location, send us back what state they're in. if we are going to get you medicine, we need to know which pharmacy to send it to. So what's really important is being able to show Google Map with the pharmacies around your current location and let the patient say, that's where I want my medicine sent. A map is just one layer of a really important stack of location services that only Google provides. The enterprise APIs, the packaging that we use, allows us to be really flexible in how we're using the service. It allows us to scale seamlessly and make the billing scalable for us.
You start by improving access. If you start by having your first medical question begin with Doctor on Demand, not only can we help you, in some of these cases, we actually might save your life.
Thank you so much.
Thank you, Doctor on Demand.
So I loved that example, and I really wanted to show it to you guys for many reasons. But why? What are you laughing about?
I just could see some funny situations.
Yeah, you think?
Don't go any further than that. But, so the Doctor on Demand was some front end company, right, that saw a need.
Mm-hmm.
They decided to use this set of APIs to reach back into what Google already had as far as databases.
Yep.
To be able to pull that out.
Right. And I liked the example not just because they're talking about what tools they used, but they also touched on a few things that we started to talk about that we're going to keep going through. But I mean, they talked about having to consider the the regulations of having to see a doctor in state. You know, it's like a lot of times the regulations are dictating the need for them to have certain geospatial buffers, right, and to return certain information for them in this case. Yeah, I mean, I liked the talk about considering the end user being somebody on their mobile phone. The end user in this case isn't somebody at a computer. They said we need a form factor that's going to work on a mobile phone. So just considering, as we watch just a tiny little use case, like what that looks like with this particular solution built, I think is really, really fascinating. And I didn't know them. Did anybody know of Doctor on Demand? I hadn't heard of them. Yeah, it's interesting. So it brought all of that to the question of disruption, which we've already kind of touched on a little bit. But again, it begins with the low-end technology. And this was a quote from one of the articles that that I thought was just super important. And it says, you know, many analysts believe that Google would encroach into ESRI's territory. And Jack Dangermond, who's the CEO of ESRI, admits that some of Google's technological advances, like its web-based maps that could be dragged around with a mouse, served as something of a wake-up call to ESRI, which had to play catch-up. And what this tells us is that without the competing factor, we wouldn't get the same kind of innovation from ESRI that we've gotten. If we didn't have Google, they would not have had any incentive to create a web-based map that had the point and click and drag and drop kind of functionality that we've come to know. So that's one of my big take-home points for today. It's just how important it is to have that kind of competition. So despite the deprecation, Google has, what do you think, I'll ask this as a question rather than, what do you think Google has contributed to the geospatial space, besides for data? We know they've contributed a lot of data. What do you think they've contributed to the geospatial space besides for the data?
Just a way of thinking spatially.
A way of thinking spatially, yeah. Exposure. Sarah.
I kind of the focus on interfaces that are, I think one article described them as simple, easy, clean, just like the user-friendly trends.
Yeah, this is kind of what I'm driving at. Jason, did you have anything else, or was that?
Integrating different business models or different it's perfect. Something that's perfect. But it's more instant access less.
Yeah, I think it's definitely fair to say that people like Doctor on Demand wouldn't have bought NavTech data to do this, probably. They would have found some other way maybe a directory of doctors in your town or something that wouldn't have had a geospatial component. And I think it's very fair to say that Google making these things accessible is driving innovation in all of these other fields because it's now considered the norm, which is the one thing that I would say I think they've contributed to is setting expectations. Consumers and businesses now expect maps that look nice, that they can interface with, that are affordable, and I think having those expectations means that all of us in the geospatial industry have to now meet that bar. We have a higher bar in terms of our end user experience than we would have had without Google. Fair enough? All right, stay with me, guys. We got a half hour, I promise. Try to get through it faster, and we can all go home and go to bed. So the last company, and I'm so excited to show you guys this, Mapbox. Did you guys know Mapbox at all? Have you logged in, checked them out? Does anybody use their interface at all? A little bit, Bianca?
Yeah, I tried to on some, it was really user-friendly, kind of like a kindergarten playground for maps. But at the end of the day, if you really wanted to edit it with your own features, you had to.
Yeah. Yep. Yeah, there's more coding. Yep, absolutely. So Mapbox overview, all right? Mapbox is a mapping platform for developers and designers, okay? Or at least that's how they pitch it, for developers and designers. And their goal is to be the base map in every mapping application. It's an aggressive goal, but that's their goal. They use OpenStreetMaps as a base map. So if you are searching on an application like Pinterest, Evernote, Foursquare, you are not searching on Google's base map. You are searching on Mapbox, which uses OpenStreetMaps base map. They just acquired 3 million square miles of digital globe imagery. And so when we talk about base map, some of these companies collect all of it themselves, but a lot of times they form partnerships to share big sets of data that they don't want to acquire themselves. So Mapbox was not going to go fly their own satellite imagery. They're going to acquire it from a partner like Digital Globe, who we'll talk more about later on in the week. I would also say imagery, important point back to Google, they have set the bar really high for imagery. I deal with imagery every day in my job, and if I had $1 for every time some customer said to me, well, the imagery looks better on my Google map than it does, I'm like, yeah, because the imagery that they have is so expensive. You can look at it on the screen, but you can't use it for anything. You have to buy it. But they've set the bar so high for consumers looking at imagery that when you actually have to go out and purchase imagery that's like half-meter data, and you'll see some of it tomorrow, it really looks pretty crappy compared to what you're used to seeing in Google Maps, which is a lot of times 15-centimeter data. It looks really good. And people now expect, again, that word expectations, Google has made it so that people expect a really sharp-looking image. So that's something that everybody's having to contend with, both on the business side and the consumer side. So anyway, Mapbox was founded in 2010. They actually bootstrapped the first couple of years. So when we talked about funding, that meant that they were essentially self-funded for quite a while. They closed a $10 million Series A round, and just this year, I think you guys read about this last night, right? They closed, how much was it? Somebody remind me. Yeah, like about 55 million. So totaling $70 million in funding, which is a lot. It's a lot for a technology company. Well, I shouldn't say it's a lot for a technology company. Tech companies get a lot of money. But for a company that is fairly new, working solely on geospatially based applications, they're not Google. It's a lot. It's a great funding round for them. So that was just in July, and they are truly, I would argue, the first company with the resources, now that they've closed this funding round, to try to compete with Google and disrupt the geospace. That's what I'm going to put forth to you. You guys can decide if you agree with me or not. So their target market when they first started, like I said, were designers, map designers who did not know how to code, or developers who did not know how to design. Okay, so somewhere in between the two, or either or. And they have a business model different than Google and different than ESRI. They're not, you could call them enterprise in some ways because they are selling to businesses. But they charge, similar to Google actually, they charge by the number of map loads So that's actually pretty similar to Google. Their pricing is a lot easier to understand if you go on their website. It's like, oh, it's like LinkedIn. Oh, you want the premium version? You're going to use 100 million map loads. You want the gold star version, that kind of thing. So they have that sort of a business model. And the money that they just raised is going mostly into data acquisition for the base map. Why do we think that they're going to spend, they just got $50 million, they're building their team, and they're spending money on data acquisition for the base map? We've kind of talked about why that matters, but they're actually going to compete in the market with Google by having base map data that Google doesn't have. It's the only way you could possibly compete with Google. So, for instance, they bought the DG satellite imagery, and they actually just bought a whole series of running and trail maps from Runkeeper. They bought the whole enchilada, so they now get added to the base map. They recently took on Apple. I mean, Apple has a terrible map, so they probably said, why not? What have we got to lose? And they released a code base. One line, developers can replace an Apple map in their app with a Mapbox map. So they made it as easy as possible for somebody to replace an Apple map with a Mapbox map. And they just said, we have nothing to lose. Go ahead. And they just opened it up to see how many people would do it. No, Mapbox. Yeah. So, and I actually don't know how that went. I would be interested to ask Paul tomorrow when we talk to him. And then very recently, Bill, they acquired a MapQuest as a partner because MapQuest is on a quest to turn their business around.
Good.
So
we need some more money here in the department.
So they've got some strategic partnerships, and their data and their platform. They kind of have a couple unique things. The first is that they render their tiles very quickly, and this is really tech speak, but they render their tiles very quickly. We all know when you're loading something slow on Google Maps, you see the boxes of tiles, right? I mean, that's where the word tiles comes from. All the imagery and all the maps come in pieces at every single zoom level. Mapbox is very, very fast when they render that, so they're delivering really good speed to their customers, which include people like Evernote and Pinterest and whatever, and a lot of other customers.
Yeah, that's a really important point. I mean, I know, I don't want to dwell on it, but it's something that we take for granted. But even just up to a few years ago, that was one of the biggest constraints of mobile systems and of systems in general. And that's where Google really really shined, because they came up with an algorithm to be able to take that really high resolution imagery and deliver it to people quick like that, instantaneously. And everybody gets frustrated with ESRI stuff, and you have the base maps in the background. We still will see it tomorrow sometimes. It just doesn't go that fast. So the fact that Mapbox can actually compete or even exceed what Google can do is a big deal.
Yeah, definitely. So the other thing that they do, that ESRI does some of this now in ArcGIS Online, but they provide some pre-baked mapping styles, so you can go in there and not be a designer at all and choose from a whole bunch of very pretty looking maps that are fully styled, and that's great for people. And the way I like to think about Mapbox is actually, I actually grappled with this concept a lot in my last job, because the last company that I was with, we were a Google Maps engine. We were building things on Google Maps engine, and I was always talking about this concept of building blocks, and I never really got really sophisticated at discussing it. Mapbox has gotten really sophisticated at talking about it, and I think the way that they explain it is smart. They have a set of tools, and you can piece them together because they are both the visualization components, the base map components, the APIs to do the analysis, and you can basically pick and choose what you need for your individual application. And what else might be important about that? I can pick this and this and this. I use it for a while, and then what? What can I maybe do as a customer if I have a kind of building block application where I can pull different things in that I need? Sure, I can update it, and when we say update, you're thinking maybe about data, and I'm going to take it one step further. I can update the application entirely. So let's say I don't like this base map anymore, or my company's growing, I need to add something on. I don't need to start from square one, build a whole new application, build a whole new set of tools or a new division in my company. I can pull one piece out and replace it with something else. So this concept, this building block foundation concept, is really important in geospatial technology because tech is moving so fast right now. We need the ability to adapt quickly. We don't want to go into a customer, spend a year building them some solution, and then a year later have it be outdated and not be able to fix it. So we need applications like this that allow us to essentially plug in, unplug this, and add something new. And that's the kind of stuff Mapbox can do.
What does leaflet fall in this?
Yeah, I actually don't really know. There's a whole series, and I think we can save that question for Paul because they went through Tile Mill first, and they've just moved to Mapbox Studio. So I'm not sure if it's still a current product or if it's now just moved to the API side or not. I don't know. But yeah, so each of these companies has a whole suite of products, right? And there's a couple that were.
Leaflet's separate too from Mapbox. Isn't it? Leaflet's complete.
But it has a Mapbox integration. You're talking about them as.
Use Leaflet, but Mapbox is an open source library for Map.
Right.
I mean, Leaflet.
Sorry, Leaflet.
Leaflet's an open source.
Okay,
library.
so you're saying
Yeah.
Leaflet separate from Mapbox,
Yeah.
what their integration is? Yeah, I don't know.
It's hard to understand.
We can ask. But yeah, I mean that kind of comes back to these. They're trying to gather. Not only I'm talking to you guys about base map pieces that they want to gather data sources to integrate, but they also are doing the same thing for their tool sets. So if there's other open source tool sets out there that are allowing them to run some operation, they want to acquire those as well. So it's a similar concept to what they're doing with trying to acquire base map data, right? So when we go back to these original concepts here, and I had, what do we need? We need base map. We need our data sources, which the customer usually always provides. We need our tools, and we said we needed tools to visualize, analyze, and distribute, right? Those were the kind of the three things. Okay. Mapbox is kind of covering all of these right now. They're doing a pretty good job. I mean, Google, for instance, isn't really doing the analyze part as much. I mean, you can use APIs maybe for, I don't know, we could talk through each of these, but I would say if we had like these 5 or 6 big components, we have to think about which companies are capable of doing which. ESRI, for instance, not generating base map data. They're buying it from someone else, or you're pulling it in from some other source. And you can access base map data in ESRI for sure, but they're not actually in the business of, collecting and reconciling and correcting base map data. But Google and Mapbox both are. So when we gotta keep those kind of big components of our geospatial products in mind as we're trying to compare these guys. So we kind of talked about this. What does Mapbox do? It's a developer platform for creating and using maps. And I'm going to click on the industries button in a second. I liked these bullet points. They're just a quick overview, and they go through pretty much exactly what we're saying here, is that you can design and style. You can upload your data sets. That's our data sources. And data source is important because we can't just have it. We need a place in which it can be compiled. We need an environment that can accept a shapefile, right? That sounds like a thing that we kind of take for granted, but we need an environment that can accept all the data sources that we have. And then we can build and publish, so I would argue that that's going to be our sort of distribute, along with some other things that we haven't really gotten into yet, but extending functionality with geocoding and directions and spatial analysis is our tool set to analyze down here. So we have these guys now offering a lot of the same things that Google has their geocoding API, Mapbox has their geocoding API. So now we have some head-to-head competition between Google and Mapbox as well.
And there's one thing that Mapbox, I think, is beginning to do very well. I don't know how competitive they are against Google, but they're way more competitive against ESRI than this, and that is developing native mobile applications for phones and stuff. It's way better than ESRI has been able to do.
Yeah, ESRI. I mean, ESRI has some legacy issues, I think, with web interface, and part of it is that they were around so much they were around before we had all of this internet integration, and so they've kind of had to do a lot of backpedaling because they had an infrastructure that wasn't web ready, you know, and they're kind of trying to fit a square peg into a round hole in a lot of ways. Did you have a question, Maggie? Can you get it compatible with phones? I think you can. Yeah, I mean, ESRI does. So ESRI does have some APIs. They do have delivery over APKs, which is basically like how you deliver certain things to a mobile phone. So yeah, you can. But most developers would tell you it's clunkier, buggier, and just not as, it's not as slick looking. It doesn't look as good. Again, Google made that bar high for the aesthetic that we, that we care about. But yeah, you can. So a couple of quick things about Mapbox. One of the really, really cool things that they're doing, we talked about Google creating all their base map data with driving cars all around. Mapbox is coming up, and I think this may be one of the more disruptive things I've heard about. Maybe I shouldn't overuse that word. I'm doing exactly what I said we shouldn't do, is like call everything disruptive. Mapbox is introducing, and I'm not sure if we can credit them with creating this idea, but they're doing it, the idea of map feedback in order to create a more intelligent base map. So they said, rather than driving cars all over and using manual correction, we have all of these people walking around with phones who are using our maps every day. And what they're actually doing is every time you're using a Mapbox-based map that's in hundreds of different applications now, they're anonymizing your data, they're pulling it all back in, and they're figuring out that it took you 5 minutes to walk from here to Atwater. So they're figuring out their driving directions, their distance, all that kind of stuff. Rather than using the resources to go out and have people drive around and measure things, they are now employing mapping feedback with
timestamp on your phone.
Using all kinds of stuff from your phone.
Google doesn't already. I just figured Google already did that.
And you know what? Maybe they do, but nothing that I've encountered has talked about Google doing this. It would sort of surprise me if they didn't, but nothing I've read has said that they do.
That's interesting.
Yeah.
Has like Apple done anything about that? Because it seems like everybody's iPhone, so it's like that's a big
Yeah, but Mapbox can work with an iPhone or an Android phone.
Isn't that how they know how? Isn't that how Google knows traffic is there though? If everybody else is slowing down, it says, oh, there must be.
Sure. Yeah. That is exactly how they used it for traffic. What I don't know is if they're using it to calculate things like distance and elevation, and I don't know more about it than that. But you'd have to think if Google, again, now we're in kind of like the ESRI mindset. 10 years ago, Google created the different ways to collect this information, and a lot of it was manual. So once you have these infrastructures in place, like here's our system for correcting this data, right? If you find a better way, and Google's great and they're highly adaptable, but it could take them now longer to pivot. We're going back to some of this business terminology, to pivot the way that they do something because they have to blow up all their existing infrastructure to do it. Whereas Mapbox, they're a 50-person company, they come up with a good idea, they build it, and they do it, right? So there are advantages to being smaller. You can be more nimble, and you can pivot faster. But if anybody finds out whether Google's already using this, I know they're using it for traffic, but I don't know if that means that that's embedded into, like if they're looking for other things. I don't know. If anybody finds out, let us know. So I think that's super interesting. So they're basically said that Mapbox is drawing on a network of devices. They have about 5,000 different customers, so those maps are distributed over about 5,000 apps and uses. And they strip out everything except for mapping-related data, and they basically use that to enhance their base data set. So for instance, Mapbox, I believe, is the only company that can tell me whether or not I'm going to be walking uphill or downhill. People can do elevation change. Oh boy, that's not good. People can do elevation change, but apparently Mapbox has some leg up on the competition when it comes to uphill or downhill. They can actually tell you a little bit more about it. I don't know. We got to find out more about that as well. The last thing that's kind of, I already said they introduced their thing to compete with Apple Maps, replace any of your Apple Maps with a Mapbox. So The advantages for Mapbox is that they have the ability with this building block concept to pull in a variety of data sources. They can use, here's the other cool thing, they can use any base map. So if you come to them and you say, guess what, I don't like OpenStreetMaps, I want to use Google, I want to use Nokia here or Navtech data, they say great. And they unplug the OpenStreetMap database and they plug in the base map that you would prefer. So when I talk about building blocks, that's what I mean. It's this highly flexible framework that allows them to basically be highly adaptable in a situation where you are not wedded to any one base map or any one way of doing something. So that's really important. Do you guys think Mapbox is a disruptive technology? I know many of you just heard about them in the last 15 minutes, but what do you think? No, everybody's shaking their head no. I see a few no's. Why not?
Well, they're not capturing a market that wasn't already captured. It sounds like they're trying to take business from it.
I'm neutral on this. I don't have an opinion yet, so convince me.
Yeah, I would agree with that. Maybe they're coming in the back door a little bit, but basically they're trying to take over a market that's there.
Yeah, I could see that.
And going back to the conversation about whether Uber was disruptive, I think this is similar to Uber in that it's not going after a new market. It's just being more innovative and more accessible that you can use. So I wouldn't call it disruptive.
Yeah.
Maybe just innovative.
Sarah?
What I do think it's disruptive though is that it does allow like a customer to do a lot of different things that they might have had to go different places for in some ways in one kind of setting, which I think is really valuable now, especially with time.
Yeah. Which really comes back to how do we define disruptive, right? Do we say that because these guys can provide more in one package than anybody else, that makes them disruptive? Could be. Yeah, I don't know. Any other thoughts on that? I think they're really, really fascinating. Really quickly, I'm going to show you guys a little bit of Mapbox. If I remember and have it open, which would be great. Where is it? There we are. All right, so if anyone hasn't seen it yet, you can go create your own username, log in. You can, this is my account. I can create a new data set. I just click new. I select a file. I can upload KML. I can upload CSV, shapefile, standard stuff. Very fun little graphics. Also, they have an amazing website. It's beautiful. If any of you care about graphic design, it's like really awesome. So we can go, I'm just going to show you a little bit about this sort of styling. So I imported a shapefile of airports, and I made some really ugly changes to my road map. But so what we can see here is these are actually all the base map features. So what they're doing is they're kind of like exposing you. This is a smart marketing play as well as making it more intuitive. It's a smart marketing play because you're sitting here and you can, I don't know, can you guys see this? All right, maybe I can make it bigger. There we go. All of a sudden you're exposed to, oh wow, this is all the data I get. And it's like right in your face that you get all this data. Now ESRI has a lot of this too when you pull in their base data sets, but it's a little easier to access here.
It's the ESRI stuff is more variable, though, those different web services. It can be very flexible or not so flexible. It's kind of hard to, it's not as consistent maybe.
So your styling is kind of basic, but I can go in here and you can style by the zoom level, which you can do in ESRI, but it's a little bit clunkier. But let's say I want to make all of my roads. Let's make them all. I don't know. Do some crazy colors. Okay, and just click out of it. Let's do something that's a little more obvious here. Land use, land covers. What do we got? Snow, crop, grass. I don't think we have land cover in here. What about administrative boundaries? That's kind of boring. Water, that's easy. Go in here, we click on our styling, and maybe we want our water to be darker. Go ahead. And now, okay, so this is weird. We can see that we got our dark blue line showing up there, but we have the actual water and water edge. That's the waterway. So that's going to be, from a geospatial perspective, that's my line. and my polygon that actually takes up the entire space is this other actual waterway. So you figure this stuff out as you go, and drag that and make it pretty blue. The other cool thing I like is what I just did actually, where you can, I'm just going to close this. You can rename stuff, you can save it, and then as you're on your map, you can actually click on something and say, okay, what is this here? Oh, this is a park. Great. Show me parks. I want my park to be really green because green is awesome. And now all my parks are like super, super green. You can see them changing color. So doing Mapbox tutorials would, you could spend a long time. Mapbox is capable of a lot of stuff. This is really just that piece for designers, right? And I would love if you guys kind of checked it out and took a look at it. Gives you a lot of freedom. You can also turn all these things on and off. You can add hill shade and terrain and all these other sort of things. Now, they have, in addition to that, I'm just going to swing back here. In addition to the Mapbox Studio, right? So that's where we think about design. So we have the maps. Oh my gosh, I love this page. It's so cool. So we have our vector maps, and I love, this is just a little walkthrough of like how these maps work. Fast and lightweight, smooth transitions, and that means they're rendering their tiles quickly and on the fly. Does anybody know what on the fly means? We use it a lot when we're talking about web mapping. It basically means that we're going to be able to make changes in real time. Okay, we don't have to like wait for either the tiles to cache, or let's say I filter for some data. I don't have to publish it and then reprint the whole thing. It's going to be changed on the fly. So I love that this map kind of moves with you as you go along to show the different aspects of what they do. They work in a lot of different industries, and they had a couple of really cool and interesting use cases that they're working on. And so we can see, obviously, in real estate, I had one or two things picked out. A lot of times they're being used in an app, but I think the more interesting use cases, and I would encourage you guys to check out what they're doing with drones, are pretty cool. But the more interesting use cases are places where they're not just being used for a pretty base map, but obviously where they're being used for more than that. So much going on here with Mapbox. We'll hear from Paul tomorrow, and I really, if you guys haven't done the reading, do it. At least, for Bill's lab tomorrow, really important. And also have some good questions for Paul tomorrow. It's a really cool opportunity to talk with somebody who's kind of at the forefront of what's going on. So to summarize everything for everybody, what we want to get out of today that I think is the most important, kind of coming back to this slide, what industry advances have gotten us to this point where we now have we sort of have an open door. Google has created a lot of interesting dynamics right now. We have the rise of cloud computing. They've contributed to the democratization of geospatial platforms. We've got global mobile access. I actually was asking the question of how many of these things has Google been driving, almost, been the primary driver of. They've been the primary driver of quite a few. So all of these kind of things are coming together, and I believe that 10 years ago when geospatial technology was kind of, when we started to think about it in a more consumer type of way, it was coming from a navigation standpoint, right? And today it's much more about real-time insights, number one, mobile technology, and indexing location data so that every industry in the world can kind of make sense of it. And, I really think that we want to see healthier competition in not only the acquisition of that data, but how we deploy it in the analytics and the cartographic visualization tools, which we'll see a couple more of them later on in the week. And with ESRI kind of serving as the geospatial monopoly, it's really interesting to see companies pushing them so that our technologies don't become stagnant and outdated. It's important. So those are my thoughts for today. But I think we're out of time, and we'll see you guys tomorrow.
Okay.
Cool. Do you have anything else to add?
Nope.
All right.